1.2 is measuring and constructing segments. We know a segment is a line that has two endpoints. The objective of this lesson is to use length and midpoint of a segment. The coordinate. A coordinate is a number that corresponds to a point. Coordinate is a vocab word, so it's very important. So, -2 corresponds to point A, and 1 corresponds to point B. -2 and 1 are coordinates for those points. The ruler postulate. Points on a number line can be matched 1-to-1 with real numbers. On a number line, every point can be paired with a number. Every number can be paired with a point. That's what it means to be 1-to-1. So if I have a point here on 3, this is the only point that can be on 3 without it being the same point. Okay? So this point here, let's name it point A. That corresponds to the number 3. Congruent. Congruent, two objects have the same size and shape. That's what it means to be congruent. So if we have a line segment here and a line segment here, this is segment A, B, this is segment D, C. If these two segments are congruent, then we put tick marks in the middle of them to show that they're congruent. So if we were writing this, we would write segment AB is congruent, so you put an equal sign with the little squiggly line on top, to segment DC. So congruent lines are line segments with the same length. The distance, also known as the length between 2 points, is the absolute value of the difference of those coordinates. So here, in this line, we know that the capital A corresponds to the point, and the little a down here is just an arbitrary number that they made up. This little a could stand for number 1, 2, something like that. And then B, capital B, is talking about the point. This little b is talking about the number. So if we looked at this example here, we would do, if we're using this formula, we would take little a, which in this case would be -2, minus little b, which would be 1, and we take the absolute value of that. So it would be the absolute value of -3, which is equal to 3. So the length of segment AB here is equal to 3. And we can see that clearly if we go 1, 2, 3. We're moving 3 units to the left, to the right. We could also go the other way if we did the absolute value of 1 minus -2. Absolute value is equal to, we know how to add negative numbers, right? We make this a big plus sign. So this would be the absolute value of 3, which is equal to 3. And that would be the same as if we went this way. 1, 2, 3. They have the same distance. So AB, when we're looking at this notation, just AB, it represents a number, while AB, this one, with the little line segment on top, represents a geometric figure.
Is William Boleda in class?
No.
No, thank you.
So, if we were saying segment AB, we would have to say is congruent to segment CD. And each one of these, each one has to have a hat on it, okay? So AB gets a hat, the equal sign gets a hat, becomes a congruent sign, and CD gets a hat. If we were saying AB, as in talking about the number, the length of AB, we would say AB is equal to the length of CD. So either all three have hats or all three don't have hats. Does that make sense?
Yes.
Find the length of BC. So what number corresponds to B?
1.
1. So we do the absolute value of 1 minus 3, which is equal to
-2.
the absolute value of -2,
2.
which is 2. So BC is equal to 2. Notice how I don't put the hat on BC because we're talking about a number. Find the length of AC. What's A? -2. So we do the absolute value of -2 minus, what's C? 3. So this would be equal to the absolute value of -5, which is equal to 5. The reason why we do the absolute value is because length can never be negative. Find the length of XY. What is X?
1.5.
So the absolute value of 1.5 minus, what's Y?
5.
5. Which would be equal to the absolute value of -3/2. Which is equal to 3/2. If we look at this, when we're going from X to Y, we go 1/2, 1.5, 2.5, 3.5. Find the length of XZ. What's X?
1.5.
1.5. Minus Z, -3. Absolute value. 1/2. This would become +3. So 1.5 plus 3 is equal to 4.5. So you'd write this XZ is equal to 4.5. This one would be XY is equal to 3.5. Okay, the segment addition postulate. If B is between A and C, then AB plus BC is equal to AC. So if I were to walk 10 miles to go to Chick-fil-A, stopped, ate lunch, walked another 12 miles to go home, how many miles did I walk? 22. So if this were 10 and this were 12, then the whole thing would be 22. So you would add the first segment, AB plus BC is equal to the whole thing. Here's an example. M is between NO, find NO. So let's take NM, 17, and we would add MO, 3x minus 5, and that would be equal to the whole thing, which is 5x plus 2. We can combine the like terms. 17 minus 5 is 12. We can subtract 3x from this side minus 3x from this side. So we would get 12 is equal to 2x plus 2. Subtract 2 from each side. 10 is equal to 2x. Divide by 2. Divide by 2. 5 is equal to x. Is that it? Did we find NO? No, right. We have to put this 5x back into here to find NO. So we would do 5 times 5 plus 2, which would be equal to 5 times 5 is 25 plus 2, 27. So NO is equal to 27. E is between DF, find DF. So let's take the first part, 3x minus 1. So we have DE. Now we need to add EF. So we would do plus 13, which is equal to the whole thing, which would be 6x. So now we can combine like terms. 3x, negative 1 plus 13 would be 12, which is equal to 6x. We need to subtract the 3x minus 3x. 12 is equal to 3x. Divide 3 from each side. You guys know how to do this, right? It's algebra. 4 is equal to x. So it's asking us to find DF, which is the whole line. So we would take 4 and plug it back in for x. 6 times 4. So DF is equal to 24. Another example. Y is between x and z. xz is equal to 3. xy is equal to 1/3. Find yz. Guys, it helps so much to draw this out first. Just reading this, it can be kind of confusing. So we know x and z with y somewhere in between. The whole thing, xz, this whole line here, is equal to 3. xy, this one, is 1/3. So we need to find this part. So we know we can add 1/3 plus yz, which would give us 3. So we can do 1 1/3 plus, we could put yz, or we could put x. We can put something that we know that's what we're looking for. So I'm going to put a, just because I know that's the number that I'm trying to find, is equal to the whole thing, which is 3. So we can subtract 1 1/3 minus 1 1/3, which would give us a is equal to 1 2/3. So we know we put a in for this question mark. So this refers to this, but we're looking for yz. So we can put yz is equal to 1 2/3. The midpoint. this says M, but it's actually talking about midpoint B of AC. So we're talking about the segment AC. So the midpoint B of segment AC is the point that bisects or divides the segment into two congruent parts. So we're saying that AB, this part, is congruent to BC. So in order to show that they're congruent, we put tick marks. And that's just saying this B is the center of AC. So AB is equal to BC. So when they say midpoint, you know it's cutting that line in half. If this line, if AC were 10, what would AB be?
10.
If the whole thing, AC, this line was 10.
5.
So this part would be 5. And what would BC be? 5. Okay? So if they use midpoint, you know that it's cutting the line in half. Or if they say bisects. Bisects, another name for cut in half. So D is the midpoint of EF. Let's draw it out first. We have the segment EF, and D is in the middle. ED, this part, is equal to 4x plus 6. DF is equal to 7x minus 9. If D is the midpoint, what do we know about ED and DF?
They're not congruent.
They would be congruent because D is the midpoint. D is the center, right? So if I'm standing at the center of this classroom and it's 10 feet that way, it would be 10 feet that way too because I'm in the middle. So we would do this. So you would start by doing 4x plus 6 is equal to 7x minus 9. We put them equal because we know if D is the midpoint, ED is congruent to DF. So we could put tick marks here just to show that these two are congruent. So how would we solve this? Let's combine like terms. These cancel, these cancel. 6 plus 9, 15. 7 minus 4, 3x. Divide by 3. 5 is equal to x. So now we take x is equal to 5 and plug it back in here. So in 4 times 5 plus 6, that is equal to 26. And then for the other one, 7 times 5 minus 9 is equal to 26. You can, since we know that they're equal, you could only plug it back into one. You know it's equal, so the other one would automatically be 26. But to show that you did it right, if you wanted to double check your work, plug it back into both and you will get the same answer when it's talking about midpoint. So what would ED be? 26. What's the length of DF? 26. And what's the length of EF, the whole line?
26 plus 26.
52. S is the midpoint of RT. RS is equal to -2. ST is equal to -3x minus 2. So we have line R, segment RT, and S is the midpoint. So we know RS is congruent to ST. RS is negative 2x, and ST is negative 3x minus 2. So we can set these equal to each other. So negative 2x is equal to negative 3x minus 2. Add 3x to both sides. These cancel. This would be x is equal to negative 2. So then we take this and plug it back in to each of these. So negative 2 times negative 2. So 4. And then ST, we have negative 3 times negative 2. 6 minus 2, which is equal to 4. So we know it's right because they are equivalent. So RS would be 4, ST 4, and RT 8. A map shows a route for a race. You are at X. You're at the beginning of the race here. 6,000 feet from the first checkpoint C. Go ahead.
Thank you.
So from X to C, this is 6,000 feet. Then the second checkpoint here is D. D is located at the midpoint between C and the end of the race Y. So we can erase this to show that from C to D is the same length as from C to Y. So this is congruent to this. The total race is 3 miles. So from X to Y, it is 3 miles. First, let's start by changing the miles to feet so we can put everything in the same unit. So how many feet are in a mile? So this would be 3 times 5,280, which is equal to 15,840. So the total length of the race would be 15,840. So we can cross out this 3 miles because we don't need it. We use this 15,840. So let's say the length from C to D is X feet. What would the length from D to Y be? X feet as well, because the length from C to D is congruent to D to Y. And we just made up X because that's what we're trying to find. We're trying to find the length of each. We know X to C, so we need to find C to D and D to Y. So we can add all 3 lengths. So 6,000 feet plus X is equal to the total 15,840. So if we subtract 6,000 from both sides and add the 2 x's together, which would give us 2x, this would be 9,840. So 9,840 divided by 2. (4,920 feet) would be the length of x. So this is the length of x, which just gives us this, and thankfully this is x2, so it gives us this. So how far apart are the two checkpoints, checkpoint C and checkpoint D? So 4,920 feet. It's important to put that feet there, that way we know we're talking about feet and not miles, because remember we had to change 3 miles from the beginning to feet. You are 11,000, I did not make these numbers up, somebody else did, so that's why they're odd. You are 1,182.5 meters from the first aid station. What is the distance to the drink station located at the midpoint between your current location and the first aid station? So this is you. And you are this would be 1,182.5 meters. So you're 1,182.5 meters from the first aid. And this is saying that the drink station is the midpoint of you and the first aid. So that would mean that from you to the drink station is equivalent to the drink station and the first aid. That's a 0.5. We're using this 1,182.5. So if we can take from me to the drink station, and we can call this x. It's congruent from the drink station to the first aid, so this would be x as well. So if we had 1,182.5 is equal to x plus x. So this would be 1,182.5 is equal to 2x. Divide by 2, divide by 2, and this would be 591.25 is equal to x. So what's the question asking? What's the distance to the drink station located at the midpoint between your current location and the first aid? So it's asking from what's the distance from you here to the drink station, which would be this. (591.25 meters. Okay, M is between N, O. Let's draw it out. We have line N, O, and M is between them. This just says that M is between them. We don't know that M is the midpoint or not. It's just somewhere in between N and O. So MO, this length here, would be 15. And MN, this length here, would be 7.6. Find NO. So what do we do? Add them. So this would be 22.6 is equal to the length of NO. S is the midpoint of TV. So let's draw the line. We have T and we have V, and we know S is the midpoint. So TS is congruent to SV. TS is equal to 4x minus 7, and SV is equal to 5x minus 15. What do we do next? Add what? Why would we add?
Yeah, you have to do. Oh, you have to do like the equal sign.
So we set them equal because we know that they're congruent. So we would do 4x minus 7 is equal to 5x minus 15. Do we get x is equal to 8? So now we can take this and plug it back into each equation. So 4 times 8 minus 7 is, what's 4 times 8?
24.
36.
32.
32. Minus 7? 25. And then let's do the second equation, 5x minus 15. X is 8, so this would be 5 times 8 minus 15. What's 5 times 8? 40 minus 15? 25. Right? TS is congruent to SV, so we know that this is going to equal this if we did our math right.
Yes.
So what's TS? 25. What's SV? 25. And what's TV? 50. Okay, so for review question 2, LH, so this longer line here bisects GK. So that means that GM is congruent to MK. So GM, we know that this part of the line is 2x plus 6. And we know that the whole line is 24. So if GM is 2x plus 6, then we know that MK, this part, is also 2x plus 6. So we would add GM, which is 2x plus 6, plus MK, which is 2x plus 6, and set that equal to 24, since we know the whole line is equal to 24. So now 2x plus 2x is equal to 4x. 6 plus 6 is equal to 12. And just bring down the 24. Minus 12. Minus 12. This would be 4x is equal to 12. And x is equal to 3. So in this problem, it's just asking us to find x. So we can stop at x is equal to 3. Is the following sometimes, always, or never true? If M is the midpoint of KL, so let's draw it out. We have line KL, and M is the midpoint. Then M, K, and L are collinear. This is always true because if we have a point that's the midpoint of a segment, then that midpoint will always be on the line. So that way, K, M, and L are always collinear. So it would be always true. So the length of a segment is always, sometimes, or never negative. A segment can never be negative. If point S is between R and V, then S lies on RV. This is the one that we just did on the slide before. So if we have R and V, and S is between them, then it's talking about S on the line RV, on the segment RV. So then S always has to be on RV. A coordinate can sometimes, always, or never be paired with a point on a number line. This is always. A coordinate always has to be paired. A coordinate is always paired with a number on a number line.